During your private pilot training, you are introduced to the airport environment, the structure of the airspace, and ways to obtain and interpret flight information. This program is designed to review these areas and to provide you with additional information pertinent to commercial and instrument operations. Let's begin with a look at the airport environment. There are several types of signs which provide you with information while taxiing. These signs are mandatory instruction, location, direction, destination, information, and runway distance remaining. First, mandatory instruction signs are used to denote an entrance to a runway or critical area, and to areas where aircraft are prohibited from entering. These signs have white lettering on a red background and usually indicate the holding position for these areas. There are three different types of location signs. The ones used to identify either a runway or taxiway have yellow lettering and a yellow border on a black background. Runway boundary and ILS critical area boundary signs have black markings on a yellow background. Geographic position markers are pink with black lettering and identify a specific location on a taxiway. Direction signs have black lettering on a yellow background and contain arrows that indicate the directions of taxiways leading from an intersection. Destination signs indicate the general direction to remote locations such as runways, terminals, military areas, civil aviation areas, and fixed-based operators. Signs that advise you of nice-to-know items are referred to as information signs. The runway distance remaining sign provides you with valuable information during takeoff or landing. The signs have a white number on a black background and are located along the side of the runway. The number indicates the distance remaining in thousands of feet. Now let's look at an example of the basic VFR markings found on a hard-surfaced runway. They consist of white runway numbers and a center line. When instrument approaches are authorized at an airport, additional markings are added to help you identify the runway environment during reduced visibility. A runway served by a non-precision instrument approach procedure has threshold markings. The runway may also have aim point markings that are located 1,000 feet from the end of the runway. A precision instrument approach runway includes touchdown zone markings that provide distance information in 500-foot increments, as well as side stripes. Thresholds can be marked in two different ways, the first being 8 vertical stripes in 2 sets of 4. A threshold can also be marked with a set of 4 to 16 stripes that indicate the width of the runway. This runway has 16 stripes on the threshold, which indicates a 200-foot wide runway. The threshold is sometimes displaced from the beginning of the paved surface due to noise abatement procedures, obstacles in the approach path, or because the pavement can't support landing loads. In this case, a solid white line across the runway marks the displaced threshold. Special markings leading to the threshold tell you what types of operations are permitted. In this example, the yellow arrows mean you can taxi, take off, and roll out within this area, but you cannot use it for landing. Yellow chevrons mark areas that cannot be used for taxiing, takeoff, or landing. In an emergency, however, this area is available to help decelerate and stop your aircraft when you're approaching from the opposite direction. Another airport marking you should be familiar with is an ILS hold line that protects the critical area of the ILS signal. A runway served by an ILS will have a sign, a hold line, or both that protects the signal from being blocked by aircraft or vehicles. Where two sets of hold lines exist, the one closest to the runway is usually marked with the runway number, while the other is marked with a sign indicating it is the ILS hold line. Another hold line marking you need to be familiar with is the hold line on a runway where land and hold short operations are in effect. At busier airports, you may be asked to participate in land and hold short operations, or LAHASO. This is an ATC procedure in which you land on a runway and hold short of an intersecting runway, taxiway, or other specific point on the airport. At airports where LAHASO takes place, there will be a hold line marked on the runway and a hold sign next to the runway. There may also be a row of white pulsing lights installed in the pavement across the runway. As the pilot in command, it is up to you to either accept or reject a LAHASO clearance. You should accept this clearance only if you are confident that, under the existing conditions, you are able to safely land and stop your aircraft in the distance available. The available landing distance for specific hold points is provided in the airport facility directory. Situational awareness is extremely important during LAHASO operations. Should you reject a LAHASO clearance, know that the LAHASO lights and signs will remain on during your approach and landing. Let's turn our attention now to airport lighting. When flying an IFR approach, you must positively identify the runway environment. During periods of low visibility, the first thing you will probably see is the approach lighting system guiding you to the runway. A common approach lighting system is this ALSF1. It is between 2,400 and 3,000 feet long. A horizontal row of white lights is located 1,000 feet from the runway threshold. One of the first things you will probably see with this system is the sequenced flashing lights. They extend to the distance marker 1,000 feet from the approach end of the runway. The ALSF2 system includes a row of red lights on each side of the center line and another row of white lights at 500 feet from the runway threshold. This system provides additional runway guidance during the more sophisticated instrument approaches. Most of the other approach lighting systems are variations of the standard system. It's very important to study the approach lights for your destination airport so that you know what to look for as you descend out of the clouds. Several visual approach slope indicator systems are available to help you maintain the proper glide path during the final descent to the runway. The most common system is the 2-bar visual approach slope indicator, or VASI. With this system, white indicates you're above the glide path, while red indicates you're below it. The correct on-glide path indication is red over white. When you're below the glide path, both bars are red. If both bars are white, you're above the glide path. Some airports have a 3-bar VASI system that provides 2 visual glide paths to the same runway. The 2 near bars give you the same glide path indications as the standard 2-bar system. The glide path formed by the 2 far bars is used by high cockpit aircraft and is about 1/4 of a degree steeper than the other glide path. The Precision Approach Path Indicator System, or PAPI, uses a single row of either 2 or 4 lights. Above the glide path, all lights are white. As you descend and move closer to the glide path, the light on the right turns red. As you intercept the glide path, the 2 indicators on the right are red, while the 2 on the left are white. When all the lights are red, you're below the glide path. The lighting on the runway itself also helps you identify the runway environment and maintain your orientation during the final approach. At some airports, you control the airport lights as well as their intensity by keying the microphone a specific number of times within a certain time period. It's important to check the aim for proper procedures to activate the various lighting systems. At most monitored airports or ones with a full-time control tower, you can request the tower or flight service station to temporarily adjust the lights for you. The taxiway lights provide direction while on taxiways, entering and exiting runways, and taxiing to other surface locations on the airport. The amount of lighting varies greatly depending on the size of the airport. Taxiways are outlined in blue lights or blue reflectors. Additional taxiway lighting may be used during periods of low visibility. For example, green taxiway centerline lights may be available at some airports. Yellow, in-pavement clearance bar lights indicate the location of holding points and intersecting taxiways. They are designed to increase awareness of holding positions during periods of low visibility. Runway guard lights are elevated or in-pavement yellow flashing lights that are installed at runway holding positions. They indicate where a taxiway intersects a runway. Stop bar lights consist of a row of red in-pavement lights. They are designed to confirm an ATC clearance to enter or cross an active runway during periods of low visibility. Pilots should never cross an illuminated red stop bar. Each year, hundreds of aircraft are destroyed or damaged by collisions with other aircraft or vehicles on the ground. The majority of these accidents are preventable. All pilots must be more vigilant and become aware of the dangers of runway incursions. Ground operations during low visibility and bad weather can challenge situational awareness. When operating at an airport, always be aware of other aircraft moving around you. Also be aware of situations that increase the likelihood of an incursion. A runway incursion can involve an aircraft, vehicle, person, or object on the ground that creates a collision hazard. A misunderstood clearance can also result in a runway incursion or a potential collision. There are several procedures that you can follow and precautions that you can take to avoid a runway incursion. Complete as many checklist items as possible before taxiing. Concentrate on your primary responsibilities. Do not become absorbed in other tasks or conversation while the aircraft is moving. Read back all clearances involving active runway crossing, hold short, and taxi into position and hold instructions. If you are unsure of your position, stop and ask for assistance. Tower-controlled airports can offer progressive taxi instructions. Report deteriorating or confusing airport markings, signs, and lighting to the airport operator or FAA officials. Also, report confusing or erroneous airport diagrams and instructions. Let's turn our attention now to a review of the National Airspace System. As a pilot, it's important that you understand which flight restrictions and aircraft equipment requirements apply to each type of airspace. Airspace is categorized into regulatory and non-regulatory airspace. These categories are further broken down into controlled airspace, uncontrolled airspace, special use airspace, and other airspace. Controlled airspace consists of those areas designated as Class A, B, C, D, and E airspace. Uncontrolled airspace is designated as Class G. The classification of airspace is relative to the complexity of the operational requirements placed on the pilot and aircraft. With this in mind, let's take a look at Class A airspace. Class A airspace extends from 18,000 feet MSL up to and including 60,000 feet MSL. To fly in Class A airspace, you must hold a current instrument rating and be on an IFR flight plan. In addition to the standard IFR equipment requirements, your aircraft must have an encoding altimeter, a transponder with mode C, and radio equipment capable of communicating with ATC on the appropriate frequencies. Instrument high altitude and route charts must be used for navigation in Class A airspace. If you're using VOR navigation, your aircraft must be equipped with DME for flights above 24,000 feet. It's important to note that a transponder with Mode C altitude reporting capability is required when operating above 10,000 feet MSL in all controlled and uncontrolled airspace within the contiguous United States and the District of Columbia. This excludes the airspace at and below 2,500 feet AGL. Many of the nation's busiest airports are surrounded by Class B airspace. The center of this controlled airspace area usually extends from the surface up to a specified altitude, while the outer areas step up from the surface to form a shape similar to an upside-down wedding cake. The upper and lower limits of each area within Class B airspace are depicted on sectional charts, and the lateral dimensions are shown by a solid blue line. Before entering Class B airspace, you must first receive clearance. Therefore, your aircraft must be equipped with a two-way radio capable of communicating with ATC. In addition, your aircraft must have a transponder with Mode C to operate within 30 nautical miles of the primary airport. This requirement extends from the surface up to 10,000 feet MSL. However, if your aircraft's transponder is inoperable, you may request a deviation from air traffic control. This request must be made at least 1 hour prior to the time you would like to enter their airspace. For IFR operations in Class B airspace, your aircraft must also be equipped with an operable VOR or TACAN receiver. In addition, you must hold at least a private pilot certificate to operate within Class B airspace. Student pilots may operate within this airspace and land at many of the airports within the surface area of this airspace, provided they comply with the restrictions and training requirements in the FARs and have the appropriate endorsement in their logbooks. However, there are some Class B primary airports that are so congested that takeoffs and landings by student pilots are prohibited. These airports are listed in FAR Part 91 and in the AIM. At certain other airports where ATC provides radar services to all aircraft, Class C airspace exists. Typically, this airspace consists of an inner circle that has a 5 nautical mile radius around the primary airport and extends from the surface up to 4,000 feet above the airport elevation. The outer circle has a 10 nautical mile radius and begins at 1,200 feet AGL. It has the same upper limit as the inner circle. There is also an outer area that extends out to 20 nautical miles from the primary airport. The ceiling of this area extends up to the limit of each approach control's delegated airspace, and the floor extends upward from the lower limit of either radar or radio coverage. Therefore, the vertical limits of this airspace varies for each Class C area. The altitudes of the inner and outer circles of Class C airspace are depicted on sectional charts, and the lateral limits are outlined with a solid magenta line. Before you can operate within the inner or outer circle, you must establish and maintain two-way communications with ATC. While not mandatory, you are strongly encouraged to establish and maintain communications with ATC when operating within the 20-mile outer area. To fly within Class C airspace, your aircraft must be equipped with an operable Mode C transponder. This requirement also extends up to 10,000 feet MSL above the lateral limits of this airspace. Class D airspace is designed to provide an orderly flow of traffic around airports with an operating control tower. Before entering this airspace, you must establish and maintain two-way radio communications with the control tower. The lateral dimensions of Class D airspace are normally based on the instrument approach procedures which service the airport. Since this airspace often contains arrival extensions, the lateral limits vary from airport to airport. On sectional charts, these limits are depicted by a blue dashed line. Sectional charts also depict the MSL ceiling of Class D airspace. Normally, this is 2,500 feet above the airport elevation, rounded off to the nearest 100-foot increment. However, if conditions warrant, the ceiling may be higher or lower than the typical 2,500 feet. In some cases, the arrival extensions may not require that you establish contact with the control tower. When this is the case, the extension area is designated as Class E airspace and will be depicted by a dashed magenta line on sectional charts. An airport with a part-time control tower is designated as Class D airspace only when the tower is in operation. The remainder of the time, this area is Class E airspace. Let's take a look at other types of Class E airspace. One area of Class E airspace covers the 48 contiguous states, the District of Columbia, and a portion of Alaska. This area begins at 14,500 feet MSL and ends at the base of Class A airspace, but does not include the airspace within 1,500 feet of the surface. Federal Airways, also known as Victor Airways, are designated as Class E airspace. These airways typically extend from 1,200 feet above ground level up to but not including 18,000 feet MSL and are normally 8 nautical miles wide. Another area of Class E airspace is found around non-towered airports which have approved instrument approach procedures. This includes part-time tower locations when the tower is closed. The purpose of this area is to allow IFR traffic to remain in controlled airspace while transitioning from the en route environment to the airport. When the base of this type of Class E airspace begins at the surface, the lateral limits are depicted on sectional charts with a dashed magenta line. When the base of this airspace begins at 700 feet AGL, the lateral limits are depicted by a magenta shaded boundary. In both cases, the vertical limit extends upward to the base of the overlying airspace. Since this varies from location to location, the upper limit is not depicted on sectional charts. In order for you to conduct VFR operations within the lateral boundaries of Class B, C, D, and E airspace, you must have a ceiling of at least 1,000 feet. In addition, VFR pilots cannot land, take off, or enter the traffic pattern unless the visibility is 3 statute miles or better. These requirements give VFR and IFR pilots the necessary visibility to see and avoid each other during approaches and departures. When weather is below VFR minimums, you may be able to obtain a special VFR clearance from ATC. This allows you to take off and land as long as you have 1 mile visibility and can remain clear of clouds. However, a special VFR clearance cannot be issued at night unless you have a current instrument rating and your airplane is equipped for instrument flight. In addition, special VFR clearances are not issued to fixed-wing aircraft during the day or night at some of the nation's busier airports. You can find a listing of these airports in FAR Part 91, Section 3 of Appendix D. At airports where special VFR is prohibited, no SVFR is printed above the airport name on sectional and terminal area charts. The last letter designation for U.S. airspace is Class G, or uncontrolled airspace. Essentially, all remaining airspace that has not been designated as Class A, B, C, D, or E is uncontrolled. ATC has no responsibility or authority for aircraft operations, nor is there a requirement for pilots to file IFR flight plans in uncontrolled airspace. However, both the pilot and aircraft are required to be fully qualified for instrument flight. Now let's look at airspeed restrictions for both controlled and uncontrolled airspace. Unless otherwise authorized, you cannot operate an aircraft faster than 250 knots when below 10,000 feet MSL, regardless of the type of airspace. When operating below 2,500 feet AGL and within 4 nautical miles of the primary airport of a Class B, C, or D airspace area, the maximum airspeed decreases to 200 knots. This 200-knot limitation also applies to aircraft operating in the airspace below the floors of Class B airspace and in a VFR corridor designated through such airspace. Another major type of airspace is called special use. You may be required to avoid these areas or to abide by certain limitations within them. For example, flight within prohibited areas is not allowed because of national security or other reasons of national welfare. In contrast, flight within a restricted area is not prohibited, although certain limitations may be imposed due to hazards in the area. VFR flights must contact the controlling agency, while an IFR clearance through the area constitutes an authorization to penetrate the airspace. Warning areas are over coastal and international waters and cannot be designated as restricted. However, the activities within these areas may be as hazardous as restricted areas. An alert area contains a high volume of pilot training or an unusual type of aerial activity. Flight within alert areas is not restricted, but you are urged to exercise extreme caution and remain alert for other traffic. Military operations areas, or MOAs, are established to separate certain military training activities from IFR traffic. When flying IFR, you may be cleared through an active MOA if ATC can provide separation. If you are flying VFR, you should exercise extreme caution within an active MOA. Another type of airspace is called other airspace areas. An example of two types of airspace in this classification are military training routes and airport advisory areas. Both IFR and VFR military training routes are depicted on sectional and government en route charts. Flight operations along these routes are typically flown below 10,000 feet MSL at speeds in excess of 250 knots. An airport advisory area exists at airports that have a flight service station but don't have an operating control tower. The FSS provides a local airport advisory service to all participating aircraft within a 10 statute mile radius. Visibility and cloud clearance minimums are also important considerations when operating in the national airspace system. When you fly VFR at or above 10,000 feet MSL and are more than 1,200 feet AGL, you're required to have a flight visibility of at least 5 statute miles. You must also have at least 1 statute mile horizontal and 1,000 feet vertical separation from all clouds. When you're below 10,000 feet MSL, but more than 1,200 feet AGL, VFR minimums require you to maintain a minimum flight visibility of 3 statute miles in controlled airspace. This also applies to uncontrolled airspace at night. During the day in uncontrolled airspace, the visibility lowers to 1 statute mile. You must also maintain 2,000 feet horizontal separation and remain 500 feet below and 1,000 feet above any clouds. If you're at or below 1,200 feet AGL in controlled airspace or uncontrolled airspace at night, regardless of MSL altitude, you must maintain a flight visibility of 3 statute miles and maintain 2,000 feet horizontal separation, 500 feet below and 1,000 feet above any clouds. However, in controlled airspace, you may operate an aircraft in an airport traffic pattern at night within 1/2 mile of the runway with a minimum visibility of 1 mile while remaining clear of clouds. You can also operate VFR in Class B airspace with 3 miles visibility and clear of clouds. At or below 1,200 feet AGL in Class G airspace during the day, you must remain clear of all clouds and maintain 1 statute mile visibility. Let's turn our attention now to a review of the flight information publications. These publications help you meet your FAR requirement to familiarize yourself with all the available information concerning each flight. The Airport Facility Directory contains information pertinent to both VFR and IFR flight planning. The directory legend provides a thorough breakdown of the abbreviations and symbols used in the airport listings. Although most of the directory is devoted to airport and facility listings, there are other sections that contain essential flight information. For example, the Special Notices section includes hard-to-find but significant information about a wide variety of subjects. You should review this section frequently for changes that might affect your flight. The remaining sections provide telephone numbers for FAA and National Weather Service outlets, Air Route Traffic Control Center frequencies, preferred IFR routes, VOR receiver checkpoints, parachute jumping areas, aeronautical chart bulletins, upper air observation stations, and en route flight advisory service outlets. The Aeronautical Information Manual, or AIM, is a comprehensive reference source that covers VFR and IFR flight operations. It includes information that helps you efficiently operate in the national airspace system, such as the various navigation aids available, aeronautical lighting and other airport visual aids, a thorough discussion of regulatory and non-regulatory airspace, and ATC procedures. Since the AIM is revised several times a year, you should study and review it periodically. Let's look now at a system that provides time-critical flight information. The Notices to Airmen publication and the NOTAM Telecommunications Network are designed to pass along changes in the national airspace system. These changes are either temporary or not available in time to include in other documents, such as the Airport Facility Directory or aeronautical charts. A NOTAM may be classified as either a NOTAM D, NOTAM L, or an FDC NOTAM. A NOTAM D contains information which could affect your decision to make a flight, such as the airport being closed, inoperative nav aids, or interruptions in radar services. This type of NOTAM is not only distributed locally, but is given distant dissemination as well. NOTAM L information is only maintained by the local FSS that is responsible for the airport and is not distributed outside the coverage area. It can include such information as men and equipment near or crossing the runways, taxiway closures, and airport lighting outages. FDC NOTAMs are issued to amend instrument approach procedures and aeronautical charts. It is extremely important to check these prior to an IFR flight and update your flight information where necessary. During your pre-flight weather briefing, you should make sure you receive the latest NOTAMs for your flight. NOTAMs printed in the Notices to Airmen publication are not normally included in the briefing. Therefore, you should always check this publication during your pre-flight planning. Another valuable reference source is the Jeppesen Airport and Information Directory, more commonly referred to as the J-AID. It is a comprehensive collection of current aeronautical and airport information. The J-AID covers the material in the AIM and Airport Facility Directory, as well as many other areas. FAR Part 135 operators are authorized